Today we're going to populate this scene, so it looks empty right now, but that's going to change soon. So we're going to restore our NPC generator, and we're also going to restore our group generator as well, and our group behavior. We made a lot of progress in the project compared to where we were when we first created these behaviors in the first episodes. So we're going to update them and integrate them into our behavior tree system. Okay, let's go back to a script that we created in the very first video. I'm talking about the NPC generator. This is it right here. I've disabled it. So the NPC generator uses an area object, and we have two areas here. So these are the areas that we created in the very first video. So I'm going to move these over here. So area 1 will be over here, and area 2 perhaps over here is fine. And then let's create a third area. Let's duplicate this. Let's call it area 3, and let's move it on the other side over here. Okay, now let's put these objects in the hierarchy of the NPC generator. That's a better way to organize it. Then let's create a new script, NPC generator. So the prefab that we're using is the civilian NPC. So the civilian NPC has a wander behavior. I'm also planning on making the civilian NPC run away from hostiles, but we'll see this in another video. Area 2 is here. Let's move area 1 a little bit closer. Or you know what? Let's give it a bigger radius, something like that. Okay, let's test NPC generation. Okay, so we have our civilians. So I still have some nav mesh geometry that's generating in odd places. So for example, on the rooftops. So with the current code of the NPC generator, there is a good chance that some civilians will spawn on the rooftops or in odd places where they'll have no path of going back to the ground, but that's okay. So we have plenty of civilians here on top of this platform and in the parking area. Now let's go ahead and restore the group generator. So let's go to the group manager and let's re-enable the group creator. So here we have the list of formations that we can use and the list of areas. Let's add our third area here. So let's add area 3. As for the NPC prefabs, so these NPCs are somewhat deprecated. So I put them in the deprecated folder. So they're using old scripts. They're not up to date. Instead, we're going to use our Sentry NPC. So for the leader prefab, let's set it at Sentry NPC. So for the leader and follower prefabs, let's set both to Sentry NPC. Now we need to modify our Sentry behavior tree to use the follow group action. Otherwise, all characters will just stand still. So first let's run the game and check if this is working. Yeah, so as I said, you can see two groups, one over here and one over there. So the NPCs in this group are using the Sentry behavior tree, so they're just standing still. They're not doing anything. Let's see if we can find another group. So we need to modify their idle branch. In case they have a group, we need them to follow that group. Otherwise, they can fall back to the Sentry idle behavior. I'm going to change the group creator. So mean group size, let's just keep it at like between 2 and max group size of 5, maybe 5 or 6. And for the group count, let's increase it to 7. Okay, let's go to our Sentry behavior tree. So let's go to the idle branch. So this is the idle branch. Here we have a sequence where the Sentry goes back to their guard post. So let's put this sequence in a separate method. So this sequence needs a post position and post direction. Let's copy this and paste it in here. So we don't need to define the default utility. I'm going to give this a name. So let's use an inline declaration. So let's call this sequence guard post, and in the create idle branch, what we can do is use a simple static priority using a selector. So let's create a selector. So we're going to add our go to Sentry post branch over here, and we're going to add our follow group action over here. Let's give the selector a default utility of 1. So we need to modify our go to Sentry post sequence. Actually, we need to do the opposite. So first we need to follow the group, and if we don't have a group, we can go back to the sentry post. Let's add an idle action just in case we don't have the sentry blackboard component. So we need to modify the follow group action. So we made the follow group action quite a while ago. It has a get utility method. So this was at a time where we didn't have a way to override the utility of actions. So we don't need this anymore because this is too specific. So we're going to remove the get utility method and in the on update. So if we don't have a group, the task will fail, and this is good. This is what we want. So in our selector, if we don't have a group, this task will fail. So here for update speed, so I don't like the fact that it's forcing the leader to set its max speed to walk speed. So I'm going to comment this or even remove it. Yeah, I'm going to remove it, but this should only be called on a follower. So I'm just going to remove this line. We don't need to force the leader to walk. So in here, in the onUpdate method, we're going to move this under here. So if we are a follower, we need to update the speed. Otherwise, the leader has full control over the speed. Let's check out the update leader method. In update leader, NPC can move is set to true. And if we have stragglers, we're going to wait for them. And this task will always return the running status. You know what we're going to do? So the follow group action will in fact fail, even if we are the group leader. So the only behavior that we're doing here for the leader is that they stop to wait for stragglers. But we can do this in the behavior tree instead. So I'm going to comment this out because here we have no way of telling the leader to wander around or do something. So for the leader, this behavior will be indeed like an idle action because the leader will not do anything and this action will always return the running status. So if has group is false, or if we are the leader, then we're going to return failure. And here we simply call update speed and update follower. Okay, so let's go back to our sentry. So let's do this in a method. So here I'm going to have another branch, leader wander. So if we are a follower, the behavior will be stuck in follow group. If not, so if we have a group and we are the leader, the behavior will be in the leader wander branch. Otherwise, if we have a sentry post, we'll go to it. Otherwise, we'll just be in the idle action. So let's create the leader wander branch. Before we do that, in the go to sentry post, let's have this sequence collapsed by default. So you know what? Here, let's use a utility selector to switch between waiting for stragglers and wandering. So we need a wander branch. Let's go to the behavior factory. So I'm going to copy the wander branch from the civilian script. Let's call it wander and let's name it here. Let's set it to collapse by default. So I'm just going to review the code. So we have a wander destination. Then we have a parallel selector. So this is the move sequence. So we pick a random destination. So now we have a constructor for pick random destination. So we're going to use it. So the first parameter that it requires is the radius. So we're going to get the radius from the wander parameters. So it's called search radius. And then we're going to set the destination to wander destination. Then we go to that destination. Again, here we're going to use the new constructor for a cleaner syntax. Okay, so we pick a random destination, then we go to it. Okay, and in the sequence, so this is the move sequence. And then the parallel selector will have a repeater with the move sequence and a wait. So we can simplify this syntax even more. So let's just use a new parallel selector here. So we made this behavior tree before making the custom constructors for all the composites, which are way more convenient in terms of syntax. So let's just use the parallel selector constructor and let's give it the repeater with the move sequence and let's give it the wait action. Let's do this in a new line. That way it's more clear. Okay, let's do it like this. So we have the parallel selector with the repeater and the wait action. So let's remove this and let's remove the parallel selector variable. Okay, so we're doing this and we're returning the wander sequence inside of a repeater. So the name should be on the repeater and also the fold out visible set to false should also be on the repeater. Then we will return it. Okay, so this is the wander sequence. Let's also create a wander method that doesn't take parameters. So I'm taking these values from the civilian NPC. We have a search radius of 20, a max wander time, set between 5 and 30 seconds, and a max wait time set between 1 and 6 seconds. So in case we don't want to bother with a wander parameters value, we can use this instead. And that's exactly what we're going to do. So let's go back to our sentry. In the leader wander, let's create a wander task. So the wander task will have a default utility of 1, and we're going to add it to the utility selector. So we're going to create a wait for stragglers sequence, and we're going to override its utility. So in the override utility func, we're going to get the reference for the NPC from the behavior tree data. If NPC is group leader and the group has stragglers, we're going to return 5, otherwise we return 0. So in fact, you know what? We don't even need this to be a sequence. So wait for stragglers could be a simple idle action, because as soon as we go out of the wander branch, then the NPC will stop. But anyway, let's add a idle action here. So anyway, let's keep it a sequence just in case we need to add more stuff to it in the future. Then let's add the sequence to the utility selector. Okay, so now this should work in theory, however, so we need this leader wander branch to fail if we don't have a group, and for this we'll add a condition to the utility selector. Let's call this condition has group. So let's create a bunch of conditions for group checking. Let's go to NPC tasks, then conditions. So this is going to be a simple condition. We're going to inherit from NPC condition, and if we have a group, we're going to return success, otherwise we return failure. Let's put this condition in the group folder. Let's also create an isGroupLeader condition. This will succeed if NPC has a group and NPC isGroupLeader is true. Okay, let's go back to our sentry. So our utility selector has the hasGroup condition. Okay, so groups are working. So as you can see, the leader is wandering around and the followers will follow the group. And in case an NPC doesn't have a group, for example, this NPC over here doesn't have a group, is going to default back to the guard post branch. So let's click on this NPC and let's go to the behavior tree viewer. Okay, so this is the idle branch. So as you can see, we have first the follow group, then we have the leader wander, then we have the guard post. So this NPC, since it doesn't belong to a group, it's in the guard post branch. So indeed, it has failed the follow group action and the leader wander action has also failed. So let's click on a follower. So let's click on this guy. Okay, so as you can see, he is in the follow group action. And now let's click on the leader. So I'm guessing this is the leader. He is in the leader wander branch, as you can see here. So I feel that this scene is too crowded. So let's reduce the number of NPCs and groups. So let's go to our NPC generator. Let's just have like 7 NPCs per area. That's good enough for civilians. Then for the groups, let's have a maximum of 5 groups. Okay, so this looks good without it being too crowded. So we have some NPCs, some groups here and there. Yeah, so this looks better. We don't want this scene to be very crowded. Okay, so for the stairs, I noticed that NPCs have a very erratic movement when going up or down the stairs. So for the player, it works fine because what I actually did on the stairs, so here I have the collider. So these are the stairs, and actually I checked convex in order to have a simplified slope. That way the movement of characters is smooth. However, for the height mesh, so here I'm showing the height mesh, it seems to be generated for each individual step, while the actual nav mesh looks like this. You know what? Let's just use an invisible ramp. So I'm going to add a cube and I'm going to match the shape of the stairs. So now that we have a shape that matches the stairs, what I'm going to do is go back to object selection mode. I'm going to hide the mesh renderer and I'm going to remove the collider from the actual stairs. So it seems like the nav mesh or the height map of the nav mesh is ignoring the convex property on the colliders. Okay. So let's generate the nav mesh again. Let's go to nav mesh surface and bay. Now let's see the height mesh. Okay, so now the height mesh is using our invisible ramp. Let's see the nav mesh. Okay, so the nav mesh looks good. Okay, now we have some NPCs going up the stairs and they seem to be doing it all right. So since the group generator is completely random, it seems that it has generated a lot of groups in one area. So here we have 3 groups and on the other sides of the map, we have no groups. Okay, so let's go back to the group creator script, which is located in scripts, groups and formations, spawners, and then group creator. So the method that we want to look at is the getRandomArea method. So here we are getting an area randomly, but this could result in the same area being used every time. So what we'll do is have a list here. In the start method, we'll create the random area list from the areas array, and we're going to shuffle the list. So we're going to loop through the list from the second index. Then we're going to choose a random index between 0 and I. Then we're going to swap the values at I and index. Then in the getRandomArea method, we're going to get the first element in the list. Then we're going to remove it and put it at the back of the list. And this will result in the groups being more evenly distributed between all the areas. So as you can see here, we have 2 groups in the area over there. We also have, I guess, 2 groups, and there I can see 1 group. So they are indeed evenly distributed. I noticed a drop in performance when we have a lot of NPCs in the scene, and that's not usual. So my guess was that it wasn't coming from the graphics. It wasn't coming from the pathfinding. So I went to the profiler. Let's open it here. Let's go to Window, Analysis. Let's open the profiler that runs in a standalone process. So on the profiler, we have these spikes in CPU usage, and they're mostly due to using physics overlap sphere in the NPC sensor. So what this tells me is that the scanning rate of NPCs is a little bit too short. So we are currently setting it at 0.25 seconds, which is too fast. So NPCs should have like 1 or 2 seconds scanning rate. For example, for civilians, we can afford to have a longer scanning rate. And also we are using physics overlap sphere instead of the version that doesn't allocate memory. So I'm guessing that also contributes to a little hit on performance. So we're going to increase the scanning rate of guards to 1 second and the scanning rate of civilians to like 3 seconds. Then we're going to modify the call to physics overlap sphere to use the version that doesn't allocate memory. Let's go to our NPC prefabs in Content, Prefabs, NPC, and Base. And here I am in the NPC prefab. So I changed the scan rate to 1 second. Then let's go to our civilian NPC and let's set the scan rate to 3 seconds. Then let's go to the Sentry NPC and let's set the scan rate to, let's keep it at 1 second. Okay, now in the code, let's go to our NPC sensor. Let's go to Scripts, NPC, Sensors, then NPC Sensor. So we're going to use physics.overlapSphere non-alloc. So this method requires that we have an array of colliders that we're going to instantiate beforehand, and we'll need to give it a size. So we're going to choose a size for this array. Since arrays, unlike lists, cannot have a dynamic size, so we have to define the size when we create this array. Then we're going to use it in the method. So this method will populate our array up to a certain size and will return that size. So in our NPC sensor script, let's create an array called colliders buffer, and we'll create a const int to define the buffer size. So we're setting the size at 100 and we're going to initialize that array with our colliders buffer size. Now let's scroll down to the scan method. So here I'm going to comment this out. We're going to use overlap sphere non-alloc and we're going to give it pretty much the same parameters, except the third parameter will be our colliders buffer and it will return the size that it has found. So we're going to replace this for each loop and we're going to use a for loop with an I going from 0 to size, and we'll get the collider variable from colliders buffer at index I. I believe a buffer size of 100 is big enough, but just for sanity, we're going to print colliders buffer size has been reached on the console. Okay, so I stand corrected. It seems that the buffer size has been reached many times, and that's because scanning not only involves other NPCs, but also any colliders in the scan mask. So if you have a lot of objects with colliders in the scene, then all of these objects will be scanned. Yeah, and I guess in this level, because the way I created the level, so each part of the ground is a separate tile. So we have a lot of these tiles and we have all of these objects. Each wall is a separate object with a collider in the default layer. So in order to reduce this buffer size, so we can work on the level geometry. However, for scanning, so we're actually using scan mask for both the characters and also the obstacles, and we're using it in two places in the code, so in the overlap sphere and in raycast all. So perhaps we should separate them so we can keep scan mask with only the character controller, because the overlap sphere is the most expensive operation. Once we have a list of close NPCs, then we can perform a raycast on them, and that would be more performant than capturing everything, including all the objects in the layer. So we'll keep the scan mask at the character controller layer, and let's go in the code. So let's add another mask. Let's call it raycast mask. Let's add a tooltip to remind ourselves what these masks are. So on the scan mask, I'm adding this mask should only contain character layers. As for the raycast mask, this mask should contain character and obstacle layers. Let's go back to our scan method. So in here, we are using the scan mask. Let's scroll down to our can raycast method. So in here, instead of the scan mask, we're going to use our raycast mask. Now all we have to do is define this raycast mask. So let's go back to the editor. I'm going to content prefab NPC base, and I'm going to change these masks on the base NPC. So let's go to NPCSensor. So for the scan mask, I'm going to set it to character controller. As for the raycast mask, I'm going to set it to character controller and default. If you hover the mouse over these elements, you will see that our tooltips are showing. It's always a good idea to remind yourself what each thing does, because a few weeks or a few months down the line, you probably would have forgotten what each of these do. Now let's make sure that our other prefabs, so our prefab variants, so the civilian NPC and the sentry NPC, let's make sure that they also have the proper values on the scan mask and the raycast mask. Okay, now let's run the game again. Okay, now we'll no longer get messages on the console. So this means that no NPC has exceeded their collider buffer size, which is a good sign. Let's open the profiler again. So on the profiler, I'm no longer getting these performance spikes. And also, if you check anywhere, the call to overlap sphere is no longer what's taking the most CPU time. In general, optimizing your game early on is a bad idea because you might be optimizing something that you will remove later. It's a much better idea to optimize when you are at the end of your development life cycle. However, this was a small change, so it doesn't matter much. And also our NPC sensor is here to stay. I don't think we're going to change it radically anytime soon. And also you have to remember that the performance that you're seeing is performance in the editor. When we'll build the game, and especially on modern hardware, the game will run much faster, even if it's not really optimized, even if it runs a little slower on the editor. So it's not really something to worry about. Okay, that's it for this video. Thank you for watching. Remember to hit like if you liked the video, and see you in the next one. Bye bye.